Alright guys, so we just finished this problem. Let's do another one. Alright, we're going to, wait a minute. Oh, I wanted to go back and do that one. I skipped. Here we are. Oh no, I cut off. Oh, I cut off numbers. Well, this does us no good, huh? I cut off numbers! Okay, go back to here. So, in addition to figuring out the interval and how confident we are about that interval, so that's why it's called a confidence interval, when we're given the standard deviation, the population standard deviation, we can also figure out the sample size we need. So like if I'm doing a survey or a study rather, and I want to be 95% confident in my results, then I can use that information along with a previous study's population standard deviation and figure out how many people I need to talk to or figure out how many measurements I need to add. All right, so let's look here. This is the formula. So that the alpha over 2 is either 1.5, 1.96, 2.58, depending if it's 90%, 95%. Ah, that was weird. Or 99%. Alright, this is population standard deviation, and this is your error. And so you just put the positive version of that. So let's look here. The things that we're going to need are z alpha over 2, our population standard deviation sigma, and our error. Alright, we want to be estimate users of the website. How many do we need to include on our sample if we want to be 95% confident? So if we want to be 95% confident, it's 1.96. And that the sample mean was within 7. So that's our error. Our population standard deviation. I was like, I just had it, guys. Let me go back and check what it was. 57. Oh, we said 53, right? 53. It said use 53. All right, and so I just popped in the formula. All right, so I'm going to do 1.96 times 53 over 7, and I'm going to square it. All right, so I'm going to do, and I'm like literally 1.96 times 53 divided by 7. Okay, and then I need to square it. So 220.2. So it's 220.2, which means it's 221. I need to ask 221 people, so that will ensure that I'm confident within 7 of friends. And so that slide should have come after this. But the sample size is related to the estimation. So how large a sample do we need to find out to make sure that we're accurate? Those things are based on the margin of error right there. The population standard deviation, it's right there. And the degrees of confidence. So you're 90%, 95%, 99%. And so remember this guy, our margin of error. And so these two are related. This is super important. As our confidence level increases, the interval widens. And as the interval widens, our precision decreases. All right, and so our precision decreases because our interval is getting bigger, but we're more confident. And so if we want to figure out our sample size, those are the 3 things that we need. And I would just write that formula down. It's a little different. We'll see a formula similar to this later. our section. So here we are. We just did that room, right? 95? Yep, show did. Show did. Show did. Let's do another one. Alright, so a scientist wants to estimate the average depth of a river. Rivers are really long. They don't stay the same depth, so you have to take lots of measurements. He wants to be 99% confident, so that means it's 2.58 for the alpha over 2. And he wants to be within 2 feet, so that's E. From a previous study, the standard population deviation is 4.33. Right, and our formula was C alpha over 2 times sigma over E squared. Alright, so I'm going to do 2.58 times 4.33 over 2 squared. Right, 2.58 times 4.33 divided by 2 squared. So I get 31.2, which means it needs to be 32. Because you can't take 0.2 of a measurement, or you can't have 0.2 of a person, you always round up. So they're going to take 32 measurements of the river, most likely evenly spaced out. And that way it ensures that the scientist is 99% accurate within 2. All right, what if he wants to be 90% accurate? Okay, so the thing that will change is this guy. All right, so C alpha over 2. He's 90%, so it's going to be 1.65. Accurate within 2 feet. Standard population standard deviation, 4.33 feet. And so we're going to do C alpha over 2 times sigma over E over 2, or squared. I'm going to do 1.65 times 0.33 over 2 squared. 1.65 times 4.33 divided by 2. I get 3.57, and then I'm going to square it. So I get 12.76. That's really 13. So if I only want to be 90% accurate, I'll do 13 of them. If I want to be 99% accurate, I'm going to do 32 of them. Measurements. All right, so just total summary of our Z distribution, when we use the Z interval, we know the population standard deviation. We use these guys for our Z alpha over 2. And then we have the mean standard deviation. So the mean doesn't change here. Let's see, X. Population standard deviation is there. He's also here. Z alpha 2 is there. Right, and then the number of items are there. Now we can go ahead if we want to and do it by hand, or I've showed you how to do it by the calculator, so whichever way you prefer. All right, so you finally finished this section. It was really long, but now go do some practice work, and I will see you next.